Alright, we're going to talk about data types in Python. And why are data types important? Well, they're important because data is represented in memory a very specific way based on its type. So we're going to talk about the data types and what you can do with them, and it's important to know what type you're dealing with because each data type can be operated on differently and processed differently. Okay, so the first one we're going to talk about is numbers. Numbers are probably the simplest data type. And in Python there are a couple different types of numbers even, right? But first we're going to talk about the integer data type. So you can declare a number data type in Python by just typing a number, right? Notice there's no quotations around it or anything. As soon as you put quotations around it, it actually changes the type to something called a string, and we'll talk about that in another video. But a number has no quotes around it, and it's just there. That's exactly what it is. It's a number. Okay, so you declare and initialize a numeric type with the variable name, setting it equal to some number. Okay. Again, the integer type here, it's a whole number, has no decimal points, and it can be positive or negative. I could throw a negative sign in front of this. This is still an integer type. It's still a number. Okay. And in Python, it doesn't really matter the size of the number. It can be as big or as small as you need it to be. That's perfectly valid. In Python, that is a number. Okay. In other languages, that would cause problems, but in Python, it doesn't care. Okay. So that's the integer type. It's very common, used a lot. The other type is called a float or floating point. It's short for floating point, which is basically just a number that has a decimal point that can be anywhere inside the number. It floats around within the number, so that's why they call it a float, I guess. But yeah, so the floating point is different from an integer because it has a decimal point in it. That's the only difference. It's still a number. It can be operated on just as any other number can be. The only difference is that an integer does not have a decimal and a float does. Okay, simple enough. You can do math on numbers, okay, and so here's some simple mathematical operations using the plus sign, addition, subtraction, multiplication, all kinds of cool things. So to use it, and in this case I'm just printing the value, and that's all you do. You use your variable name. You can add to it some other number, right? This could be a float. It could be, it could be whatever, any number type, and it'll add it together because they're numbers, and a computer knows how to operate on numbers with math, right? So you can do addition, subtraction. Here's multiplication. You can even have multiple operators all in one line. Okay. There's also exponents you can do, and that's just done with the double asterisk or the double multiplication sign or whatever. That just basically says take the integer and raise it to the third power. So this is my integer cubed, and that can be any number as well. That's my integer to the 23rd power. So you can do whatever you need to with exponents. And a quick note on that, to take a square root of a number, if you were unaware, the square root is also the same as raised to the half power, the 1/2 power. So that would be taking the square root of a number. So it's kind of cool. Just a quick tidbit there. Now there is the order of operations. That's important because this may function differently depending on whether you've got multiplications, additions, where the parentheses are. So it's important to know that operates differently than this. Okay. So multiplication comes first. So in this case, what it does is it multiplies here, the 4 times 6, and then it adds it to my integer. Whereas if you wanted to do it the other way and exclusively or implicitly, explicitly, I gotta get the right word here. If you want to explicitly add the integer first to 4 and then multiply, you can group that in the parentheses, just like you do in your normal algebra classes. You put parentheses around it, you do those first. Same thing with computer programming and Python. Okay. Now you can do division on numbers as well. Okay. Now integer division uses 2 slashes, and I'll show you the difference here. So you can, 1 slash is just division. So in this case, 10 divided by 3 is 3.3333333 forever. And yeah, that just does normal division. Even though these are integer types, you're doing a normal division, Python will convert that to a float automatically. If you want to stick to just integer division, you can do that using 2 slashes, 2 forward slashes. And what that does is it does the division and then just throws away any decimal point that's left over, any decimal point that's on there. So 10 divided by 3 using integer division is just 3, not 3.0, not 3.333, it's just 3. It throws away anything after the 3 with the decimal point when you're using integer division. Okay, that can be handy for different things. And I have a spelling typo here. That can be handy for different things, but just know that that's how you would do that. Okay, now it throws away, so the integer division throws away the remainder. Okay, you can get the remainder from the division if you want just that remainder portion using what's called the modulo operator, and that's just this % sign as the operator. So 10 modulo 3, it will print 1 because 10 divided by 3 is 3 with 1 remaining. So it's going to print the 1 remaining portion. Okay, now if I were to do this one here, 10 modulo 2, that's going to print 0 because 10 divided by 2 is 5 with 0 remainder. Okay, so it's going to print that remainder portion, in this case, 0. All right, and this right here, this modulo 2, is actually very common for determining if a number is odd or even. So if the modulo operator by 2, any number modulo 2, if it returns 0, then it's an even number. If it returns 1, it's odd. So that's a good tip to know there as well. Let's see what's next here. All right, you can also modify the value of a variable in place. This is in place modification kind of. So you don't have to create a new variable and do some change to it and then put it back into the original variable or anything like that. You can do it all in one line here. So what this does is you have your variable, right, the myInteger, that holds some value. And then what you're going to do is you're going to first evaluate this portion, or what Python does is it takes the myInteger, whatever the current value is, adds 10 to it, and then assigns it into myInteger. Okay, so it just basically overwrites it with the new value. So as you can see here, if I were to run this and then print the new value of myInteger, it would print 22 because prior I had set it to 12, right? Up here at the top, we set it to 12. All right, and you can do the same thing with any other operator, right? Multiplication, division, even the exponent. You do your variable equals your current value of the variable, and then some kind of a math operator on it, and it reassigns it to that value, it overwrites it. Okay, so that's very common as well. Good to know about. Next is there's a shorthand for this as well. You can do in-place modification. So this myInteger plus equals 10 is the exact same thing as myInteger equals myInteger plus 10. It's just a shorter way to write it. It's saying myInteger, add 10, and then assign it back to myInteger. That's what it does. So as you can see, if I run this, now myInteger was increased by 10 here, and now we're going to increase it by 10 again, and then we print it, so we get 32. Same with myFloat. And again, you can do this with any operator, right? Division, multiplication, whatever you need to. You just do the operator sign, and then the equal sign, single equal sign, and then the value that you're modifying by. Okay, so that's a shorthand way to do it. Also very common to do. Helps save a little bit of typing time, and it looks kind of cool too. It actually shortens the line, makes it a little simpler and easier to read. Especially if you have a big long variable name, then you don't want to type it twice. All right. Now I also want to mention here that you can change the type of the number if you need to, for whatever reason, right? Let's say you have an integer value and you need it to be a float for some reason. you could change that, or vice versa. So in this case, what I'm doing is I'm taking the my float value, I'm converting it to an int using this integer that's called casting. So you cast it to an integer, the integer cast function, and then it prints it as the integer. So you'll see here, print the 5, okay? But anything that's left over when you're converting from a float to an integer, you're going to lose some precision. So an integer has no decimal points. So if you're converting a float to an integer, if there is anything in the decimal point value, it just goes away. It's gone. It doesn't save it anywhere. It doesn't do anything. It's just poof, it's gone. Right? So that just prints 5. Even though this, typically you'd look at this and you go, oh, well, I'll round it to 6. That doesn't do it. Right? It just cuts off whatever's left over. And then for the float, here I'm converting my integer. I'm casting it to a float type, and it just adds on the decimal. Since it was an integer before, it just puts on 0.0 because there's nothing there. So that's how you can cast to different types if you need to. Let's see here. I also want to mention, and that can be actually useful for this next section here. So only integers can be used to access the values of a list, and you'll see lists in another video. I'll talk about that data type. But basically, what that means is a list has a list of values, and you can access each one using its index in the list, right? So if you want to access it, you have to use an integer value. You can't use a float. If I were to try to run this part, let's see. If I try to run this, you'll see I get an error. Right? List indices must be integers or slices, not floats. So just goes to show right there that that's a problem. I can't use a float value to access a list using the index. Okay. And the last thing I'm really going to mention here is that you can print these out. You can format them if you need to. Here's another, I'm setting my integer to another value here, 4,245. Then I'm setting my float equal to 75.448, blah, 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 a whole bunch of stuff. You can print the value. So let's see here what happens if I print my integer. You'll notice it prints the 4245. That's fine and cool. Now I can format it using this little format syntax, and I'll have another video on this as well. This is just kind of showing you what you can do with integers, or with number types in Python. But here you'll see if I format it, what this is doing is it's making it 8 characters long and puts zeros at the beginning if it's less than 8 characters. Okay, so let's see what this looks like when I print it. And here you can see it printed the first one, and then I printed it. Now you'll see it's 8 characters long, or 8 digits long, and it has zeros at the beginning, leading zeros. Okay, same with the float. Let's see what happens. I'll print the float part. So it prints the 75.4, a whole bunch of numbers. Actually, it looks like all of them. If I want to, I can round it. Right? I can use this specification here. The .5f means round it to 5 decimal points. So if I run this, you'll see now I've only got 5 decimal points, and it rounded it. Okay, as you can see, I've got 2.65. Or I'm sorry, 448.265, and then it rounded it to 44827. Okay. You can also, let's say you need to print something for like a dollar amount. Right? You're going to probably want to round that to 2 decimal points, because more than that is really kind of weird for a dollar. And then you want to prefix it with this dollar sign or whatever currency sign you want to use there. But you can do that as well. So now we run that, and you'll see it shows $75.45, $75.45. All right, and then a quick note on that. When you format it like this, it doesn't actually change the value inside the variable. So you can format it as many times as you want, but the value inside my float does not change. Okay, so that's the quick rundown on the numeric types in Python. It's important to know what data type you're dealing with, because you'll have to operate it on it differently. Just like you saw the math operators earlier. If you're using numbers, you can do math on them, but if you're using a different data type like a word or letters, you're not going to be able to do the same kind of math on it. So it's important to know your data types, and yeah, that's the numeric data type.